The Earth's crust is made up of tectonic plates that are constantly moving, colliding, and sliding against each other. This movement is due to the heat generated by the molten rock in the Earth's mantle, which causes the plates to shift and change over time. Most earthquakes occur when two tectonic plates collide, with one plate sliding under the other in a process called subduction. This movement creates a lot of friction between the two plates, which can cause them to become stuck together. As the plates continue to move, pressure builds up along the fault line. This pressure can cause the rocks to suddenly break and shift, releasing energy in the form of seismic waves. The energy released during an earthquake is felt as seismic waves, which travel through the Earth's crust and cause the ground to shake. The strength or magnitude of an earthquake is measured using a seismometer, which records the amplitude of the seismic waves. While most earthquakes are caused by the movement of tectonic plates, other factors can also trigger seismic activity. For example, the movement of magma within a volcano can cause the ground to shake, as can large landslides or human activities like fracking. Scientists continue to study earthquakes to better understand their causes and predict when and where earthquakes are most likely to occur. This information can help to improve earthquake-resistant building design and minimize the impact of earthquakes on human populations. While earthquakes can be devastating, they are also an essential part of the Earth's natural processes. Understanding how earthquakes are formed can help us to better understand the Earth's dynamic and constantly changing systems. Other factors can also contribute to the formation of earthquakes. For example, volcanic activity can cause earthquakes when the movement of magma puts pressure on the surrounding rocks. Human activities such as fracking and underground nuclear testing can also trigger earthquakes by altering the stress and pressure in the Earth's crust. Earthquakes are a natural occurrence and are an essential part of the Earth's geological processes. While they can cause significant damage and loss of life, scientists continue to study earthquakes to better understand how they form and how to minimize their impact on human populations. India is one of the most seismically active regions in the world, with a long history of devastating earthquakes. One of the main reasons for this is the location of the Indian Plate. The Indian Plate is slowly moving northwards towards the Eurasian Plate at a rate of approximately 5 centimeters per year. As the Indian Plate moves, it collides with the Eurasian Plate, which is much larger and more massive. The collision of the two plates has resulted in the formation of the Himalayan mountain range, which is still rising at a rate of approximately 5 millimeters per year. The constant movement of the Indian Plate creates enormous pressure and stress along the fault lines, leading to frequent earthquakes. The Himalayan region is particularly prone to earthquakes due to the complex and irregular nature of the fault lines, as well as the steep and rugged terrain. In addition, the region is densely populated, with many large cities and towns built in areas that are at high risk of seismic activity. To minimize the impact of earthquakes, the Indian government and international organizations have implemented a range of measures, including earthquake-resistant building codes, early warning systems, and emergency preparedness drills. While earthquakes in India can be devastating, understanding the causes and risks associated with seismic activity can help us to better prepare and respond to earthquakes in the future. India is located in a seismically active region with several major tectonic plates and fault lines passing through its territory. This makes the country vulnerable to earthquakes, and several earthquake-prone zones have been identified based on historical data and geological studies. Here are some of the earthquake zones in India. 1. Himalayan Belt. This zone covers the entire Himalayan mountain range, which runs from Jammu and Kashmir in the northwest to Arunachal Pradesh in the northeast. The Himalayas are formed due to the collision of the Indian and Eurasian tectonic plates, which has resulted in numerous earthquakes over the years. The Himalayan belt is considered to be the most seismically active zone in the country. 2. Indo-Gangetic Plain. This zone covers the northern part of India, including states like Uttar Pradesh, Bihar, and West Bengal. The Indo-Gangetic Plain is a sedimentary basin formed by the deposition of alluvial soils brought down by rivers like the Ganga and the Brahmaputra. 3. Kutch and Saurashtra region. This zone covers the western part of India, including the state of Gujarat. The region is located near the intersection of the Indian, Arabian, and Eurasian tectonic plates, which has resulted in several major earthquakes over the years. The most devastating earthquake in recent history, the Bhuj earthquake of 2001, occurred in this region. 4. Central India. This zone covers the central part of India, including the states of Madhya Pradesh and Chhattisgarh. The region is seismically active due to the presence of several fault lines and underground reservoirs of magma. 5. Northeastern region. This zone covers the northeastern part of India, including the states of Assam, Meghalaya, and Mizoram. The region is located near the intersection of the Indian, Eurasian, and Burmese tectonic plates, which has resulted in several major earthquakes over the years. It is important to note that earthquakes can occur in other parts of the country as well, and seismic activity can be unpredictable. It is therefore important for individuals and communities to be aware of the potential for earthquakes and to take necessary precautions to ensure their safety.